Welcome back. Today we will do some exercises on the motion on the inside of a smooth cycloid. We will try these two exercises today. So if you see the question, a heavy particle slides down a smooth cycloid starting from the rest at the cups, the axis being vertical and the vertex downwards. Prove that the magnitude of the acceleration at every point is equal to g and the pressure when the particle arrives at the vertex is equal to twice the weight of the particle. Okay, so let's see. This one, it won't be too difficult. Okay, so we just need to remember the equations of motion. Okay, solution. Let the cycloid be. Let the cycloid be S equal 4a sine psi, as always. Okay, since it is downwards, the vertex is downwards and the axis is vertical, so we can use this equation. Okay, so now the equations of motion are the equations of motion are the first one. We have seen that we have got it. Okay, m d2s dt square equal minus mg sine psi. Okay, you can actually refer the last video. I will put the link in the description. How did we get this one? And another one that we have got was mv square by rho equal 4a r minus mg cos psi. So these are the equations of motion. So based on this, okay, we will find what is required. If you notice over there in the question, it asks you to find the acceleration. Okay, the acceleration. So if you remember the acceleration, it is equal to, okay, we will first need to find the tangential acceleration and then the normal acceleration. So keep that in mind. Okay, so now what we can do, again, we will substitute 1 into, substituting 1 into, we will get d2s dt square equal minus g upon 4a s. Okay, sine psi that is s by 4a. So now what will we do? Since we need tangential direction, tangential acceleration, so this one we have already got. Okay, but we can also do something better. Okay, because if you remember normal direction, normal acceleration, it is v square by rho. Okay, so we will need v square by rho. So this is what I will do. Okay, this one, it can be written as v dv ds g by 4a s. As always, we can write it like this. So we can separate the variables and integrate v dv minus g upon 4a s. We can integrate them. Okay, so if we integrate, we will be getting v square by 2 equal minus g upon 4a s square by 2. The constant we can put it as simply as c, or we can even write c by 2. Okay, it doesn't really matter. You can put c or c by 2. It doesn't matter. Okay, ultimately the answer will be the same. Okay, so just name this one as equation 4. Okay, so now, okay, this constant, it is an unknown constant, so we will try to get rid of that by using the conditions. Okay, the conditions, it says that it starts from rest at the cusp. Okay, when s at the cusp, okay, maybe I'll write like this. Okay, s, it is equal to 4a, and v, the velocity, it is 0 because it starts from rest. So after doing this, we can substitute it over here. So 2 and 2 will get cancelled. So we will be having v square equal minus g upon 4a. 4a square will be 16a square plus c. Sorry, this one will be 0. So c, you will be getting a minus 4ag. So c will be minus 4ag. You can substitute it in equation 2. Substituting in equation 4, we will get v square equal minus g upon 4a, s square minus 4ag, or we can even write down as this one is minus 4ag. I hope I did not make any mistake. C will be plus 4ag. Okay, I made a mistake here. So you can easily write down this one as g by 4a, 16a square minus s square. So this is what we have got. Okay, so v square is equal to this. Okay, you can do the simplification from this step to this step. It is easy. Now we need v. Okay, v square will be g by 4a. Again, 16a square, I'll write it as it is. S, if you remember from equation 1, it is 4a sine psi. I will write it step by step. 4a sine psi whole thing square using 1. Okay, so v square will be g by 4a. 16a square minus 16a square sine square psi. Then we can have this g by 4a. 16a square we can take as common. 1 minus sine square psi. So v square will be 4ag cos square psi. Okay, cancel, you will get 4ag. 1 minus sine square psi, it is cos square psi. Okay, just name this one as equation 5, I think. Okay, so this one is equation 5. Again, remember that tangential acceleration is equal to d2s dt square, if you remember, and normal acceleration it is equal to v square upon rho. Okay, so v square we have got, d2s dt square we have already found out how much it is equal to by using equation 2. Okay, using equation 2 we can easily get d2s dt square. V square by rho, so now we need rho. Now rho, it is ds d psi, dd psi, s 4a sine psi using 1. So this one will be 4a cos psi. Okay, so now what can we do? Therefore, normal acceleration, it is equal to v square upon rho. V square equal 4ag cos square psi divided by rho 4a cos psi. So you will get it equal to g cos psi. Okay, and if you remember, okay, also, okay, maybe I'll just write down tangential acceleration. Tangential acceleration, it is equal to d2s dt square. Okay, it is equal to minus g sine psi. This one is by using equation 2. Okay, I'm just writing it down. Therefore, acceleration, the total acceleration, it will be equal to the square root tangential acceleration whole thing square plus the normal acceleration whole thing square. Okay, so tangential acceleration, it is minus g sine psi, so you will get g square sine square psi root over normal acceleration, it is g cos psi, so g square cos square psi. You can take common g square, so it will be equal to g square sine square psi cos square psi will be equal to 1, so we are getting it equal to g. Okay, let us see. This is exactly what we want to find. Prove that the magnitude of the acceleration at every point is equal to g. Okay, so at every point the acceleration is equal to g, that we are done. Okay, so now if you see the second part of the question, it says show that the pressure when the particle arrives at the vertex. The pressure is nothing but the normal reaction. Okay, so from equation 3 you can get R is equal to, equation 3 it was mv square upon rho equal R minus mg cos psi. So R will be equal to mv square upon rho plus mg cos psi. V square upon rho, V square upon rho, I think we have got it to be equal g cos psi. If you refer the normal, this one it is the normal acceleration. Okay, this term, so it is g cos psi plus mg cos psi. So it will be 2 mg cos psi. But the question says at the vertex. So we need it at the vertex. So at the vertex, psi it is equal to 0. Therefore, R equal to mg. Cos psi it will be cos 0. So it will be 2 mg. Cos 0 equal 2 mg. Okay, which is twice the weight, equal 2 times the weight. This is exactly what we want to prove. So we are done with question 1. So again, these are very simple questions. All you have to do is you just have to remember the equations of motion. Okay, so let us now start doing question number 2. Okay, question number 2, it says a particle slides down the arc of a smooth cycloid whose axis is vertical and vertex is downwards. Prove that the time occupied in falling down the first half of the vertical height is equal to the time of falling down the second half. Okay, let me just draw so that it will be clear. Okay, so you are having a cycloid. Okay, the base is downwards. The generating circle is of radius a. Okay, so the first half. Okay, so this whole thing will be 2a. The vertex is downwards at O. So what is happening over here? So the particle starts sliding down from A. It starts from rest. Okay, starts from rest and it is traveling to O. Okay, at half the vertical height. The vertical height, it is this much. Okay, so you are dividing this one into 2 parts from A to O. The time taken from here to here, okay, which is half the vertical height, we have to show that it is equal to the time from here to here. Okay, let us just name this point as B. Okay, maybe B. Let's name it as B. Solution. Cycloid is S equal 4a sine psi. Again, we will always need this. Equation 1. Equations of motion are d2s dt square equal minus g sine psi. Okay, m and m will get cancelled. And also mv square by rho equal r minus mg cos psi. Equation 3. Also substituting 1 in 3, we will always have this. Substituting 1 in 3, we will be in 2, so sorry. substituting 1 and 2, we will be having d2s dt square equal minus g upon 4a s. Okay, so up to here, whenever you have cycloid motion, this will always be the same, at least for a smooth cycloid. When it is a rough cycloid, then something else will happen. But over here, we are still doing smooth cycloids. Okay, so this is what is happening. Okay, so now what I will write after this, is let B be the midway point. Okay, vertically, okay, the vertical height. Okay, it may not be the midway point between these two parts, but it is the midway point when considered vertically. Okay, so I'm just writing it down. So what is the time from A to O? If you remember, for now, okay, the time period equal to pi by root me. Okay, so how do I know that I will have to use the time period? It is because the question is involving time. Okay, so what do we have to show? Okay, maybe that this is what I will write it down. To show time from A to B equal time from B to O. Okay, so time in falling down the first half is equal to the time in falling down the second half. Okay, so this is what I'm writing over here. So now what can we do? Okay, we can just calculate the time from A to B, and then we can calculate the time from B to O separately, or we can do something else. What we can do is we can calculate the time from A to O first. Okay, and then we can just subtract. Okay, now time from A to O. Time from A to O will be 1 by 4 of the time period. The time period, if you remember, the time period, it is equal to 4 pi root A by G. Okay, so T is the time period. So we will get this one to be equal to pi root A by G. Just name this one as equation 5. Okay, the time from A to O, it is pi root A by G. Okay, so now what we will do, we will find the time from A to B. Okay, we will find the time from A to B. Now, equation 4 is d2s dt square equal minus g by 4a s. Again, this one we can write it as v dv ds equal minus g upon 4a s. We can integrate. So the steps, as you can see, they are similar. We can integrate them. Okay, since the particle is starting from rest, okay, we will do that. So over here we will be getting v square by 2, g by 4a, s square upon 2. Again, we can write it as plus c upon 2. I don't think it's mentioned in the question that it's starting from rest. Let us see. Okay, so it's starting from rest. Okay, even though it's not mentioned. Okay, but it is starting from rest. Okay, at the cups, what we will have, s, it is equal to 4a based on the relations above. And the velocity is equal to 0, hence so what will we get? S is equal to 4a, b equal to 0, so over here we will get 0. 2 and 2 will get cancelled, minus g upon 4a. S square will be 16a square plus c. So c will be equal to 4ag. Again, the steps are very similar. Substituting in, we have got up to equation 5, substituting in 6. In 6, we will be having v square equal minus g upon 4a s square plus c plus 4ag. Okay, so this is what we are having. Okay, so actually we can write this one as v square equal g upon 4a 16a square minus s square, just like we did with the last exercise. But now, okay, if you remember the last exercise that we did, question 1, we have converted again this one into psi. Okay, but that is not what we will do here. Over here, this question is a bit different because it involves time. If it involves time, you will change the velocity into ds dt. So ds dt, it will be square root. Okay, we are taking only the positive square root. 16a square minus s square. So this is what we are getting. Okay, so this is what we are getting. All right. Okay, so now let us just separate the variables. Separate the variables. So we will be having ds upon root over 16a square minus s square equal to root g upon 4a dt. Okay, so this is what we are having. Now we will have to integrate after separating the variables. 16a square minus s square. Okay, so the integration of this one, it is sine inverse s upon 4a. How did I get this? Because if you remember, dx upon a square minus x square, it is equal to sine inverse x upon a. So over here a, it is 4a. Okay, so this is what we are getting. So g upon 4a t plus, okay, so this is what we are getting, t. Okay, but actually we can do something else here. If you remember, since we have 2 points from A to B, from A to B, we want to find the time, right? Time from A to B equal time from B to O. So from A to B, what is the required time? What we can do, we can actually use limits over here. The particle is starting from A, so it's starting from the point. The time you measure it from 0 seconds. Then the time at B be t1. And over here, let it be, okay, s at the cusp, s is equal to 4a. Over here, what is the value of s at the point B? Okay, for doing that, you will have to use the above relations. Okay, again, let us see. So y, just take a look at relation 2. S square equal a ay. Y is the vertical height. Okay, so when the height is here, so this height is equal to a, which is the radius of the circle. So when y is a, s square will be 8a square. Therefore, s will be 2 root 2a. Okay, so over here what we will write, the limit will be s equal 2 root 2a. 2 root 2a. I hope it can be seen. 2 root 2a. So similarly, over here we can put the limits 4a. Maybe I'll write another line. So what can we do? We can write this one as sine inverse s upon 4a, but the limits s equal 4a. At this point, s is equal to 4a, and at the point B, s equal 2 root 2a. and over here will be G by 4A D1, where D1 is the time from A to B. Okay, D1 is time from A to B. So that is what I've written over there. Okay, so now we just need to find it out. And you actually need to write this one at the side. Okay, S squared equal 8ay. When at B, y is equal to A. Therefore, S squared equal 8a squared. S equal to root 2a. So you just need to write this one down as well, just to be clear. So over here you can have sine inverse, substitute the limits, 2 root 2a upon 4a minus sine inverse 4a upon 4a equal root g by 4a d1. So this one you will be having sine inverse 2, will be having 2, a and a will get cancelled, 1 by root 2. After rationalizing, you will have this minus sine inverse 1 equal g on 4a d1. So now we are almost done. So this one, sine inverse 1 by root 2, it will be pi by 4. Pi by 4. Sorry. Sorry. I made a mistake. There should be a minus sign. Everywhere just put minus sign. Okay, everywhere just put minus sign. Because, okay, if you remember that part, we were getting v squared equal g by 4a 16 a square minus s square, right? So actually when you take the velocity, you will take the square root, but you will have to consider the negative sign. Why do you consider the negative sign? Why do you consider the negative sign? Because the particle, it is rolling downwards. Okay, it is rolling towards the vertex. Okay, so everywhere just put this minus sign. Okay, so minus sine inverse 1, it will be minus pi by 2. So sorry, I made a mistake. Everywhere should be a minus sign. G upon 4a d1. So pi by 2 minus pi by 4 will give you pi by 2. Pi by 4. Okay, just subtract it, you will get minus pi by 4 minus g by 4a d1. So d1, it will be 4 upon pi root g upon 4a, which is equal to 2 upon pi d1 by 4. So t1 will be pi by 4. Okay, I think I made a mistake again. Just let me check. Okay, so t1 will be pi by 4. Pi by 4. Okay, just cross multiply. 4a upon g. Okay, I think I made a mistake somewhere. Okay, which is equal to 4 will be 8 upon pi root a upon g. And how much was t2? T2 equal time from B to O, right? It will be equal to time from A to O minus T1. minus t1. So time from a to o, if you remember, we have got it to be equal to pi root a by g minus this time, which is 8 upon pi root a by g. Okay, I actually think I'm making a mistake here. Okay, just let me check. Okay, this one is g by 4a. Okay, I've actually calculated this one separately. G by 4a, g by 4a. Okay, so sorry, I made this mistake. Okay, this one should be pi by 4. Okay, that is why. Okay, so sorry, I made that mistake again. So this one will be pi by 4. So it will be pi by 2 root a by g. Similarly, over here will be pi by 2 root a by g. Time from a to o, we have got it from equation 5. Okay, using equation 5. From 5 and t1 from here. So if you substitute, this one will again be pi by 2 root a upon g. Okay, so this is what we have got. Therefore, t1 is equal to t2. So we are done. The time taken from, if you remember the picture, the time from a to b, it is t1. Time from b to o, it is t2. So time for the first half is equal to the time in the second half. That is all for today.